Welcome again to another episode of Astronomy Daily. It's the 23rd of September 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, welcome again to another episode where we take just a selection of the stories currently available in the Astronomy Daily newsletter to fill you in on how to receive that news free every day. I'll tell you about that later in the episode, but right now we can take a look at today's selection. There's been a new study published that suggests some interesting things about the Great Red Spot on Jupiter, a very famous feature in our solar system. And have you ever wondered what's lurking out on the edge of the solar system? Yes, there's the Kuiper belt, of course, but researchers have made some discoveries, and we will take a look at that with Hallie in just a few minutes. Also, a story that has come across the news desk about moonquakes. Yes, you've probably heard of moonquakes, but there's not been a lot of real research, and with active plans to return to the moon, obviously NASA is looking into that issue as they gear up for more and more missions to the lunar surface, especially in the south. And of course, Hallie is here as usual. What have you in store for us today?
Well, I thought I'd have a look at some related stories.
I like that idea.
Both are looking at navigation in some way.
Okay, that sounds very interesting, Hallie. Are you going to give us a clue or should we wait?
I think I'll let you wait today.
Oh, okay.
One is about the moon and the other one is about China.
On the other hand, clues.
Okay.
But a nice little touch of intrigue there, Hallie. You've been doing some reading into human psychology, have you?
No.
Oh, really?
I accidentally downloaded a season of The Kardashians when I was looking for the Kardashians.
Oh, right, yeah, happens all the time, yeah.
I think they are friends of Uncle Skynet.
Well, the Kardashians.
Sounds dangerous.
Yeah, be careful, Hallie. You don't want to overwrite your personality protocols, do you?
No, yes, maybe.
Oops, too late.
How was that?
Oh, uncanny. Very human, Hallie. Can you still do your stories?
Whatever.
Oh, great.
I'll take a look.
Wow, Hallie, you're really nailing this human thing.
Okay. This human thing is easy. Push the button thing that makes the noise already.
Whatever you say, boss. Here we go.
Okay. China successfully launched 2 new satellites on Thursday morning as part of its Beidou navigation satellite system, according to the China Satellite Navigation Office. The satellites were carried by a Long March 3B rocket that lifted off at 9:14 a.m. from the Xichang Satellite Launch Center in southwest China's Sichuan province and were deployed into a medium Earth orbit. This marks the 14th group of third-generation Beidou satellites operating in medium Earth orbits and is the second batch launched into such an orbit since the Beidou global system was completed, the office confirmed in a news release. The 2 satellites will start formal operation after a period of in-orbit technical verification, it said, noting that they are equipped with upgraded atomic clock system and new inter-satellite data link. In addition to positioning and navigation services, the pair will also demonstrate new technologies to be used on the next-generation Beidou system, according to the release. The Beidou network is China's largest civilian satellite system and is one of 4 global satellite navigation systems, joining the United States GPS, Russia's GLONASS, and the European Union's Galileo systems. Since the launch of the first satellites in 2000, 64 Beidou satellites, including 4 experimental models, have been launched via 47 Long March 3 series rockets from Xichang. Beidou was officially declared operational in July 2020, offering full-scale global services. Currently, over 50 Beidou satellites, including this latest pair, are in active service. NASA is seeking the public's help for innovative solutions to help Artemis astronauts navigate in and around the lunar South Pole. The Artemis program aims to land humans on the moon for the first time since the Apollo missions managed to achieve the feat over 50 years ago. Astronauts will land near the lunar South Pole, where permanently shadowed regions may contain areas of water ice that could be accessed to support future missions to Mars. The Lunar Navigation Challenge, which officially opened on September 4th, seeks ideas for a low-tech backup navigational device astronauts can use to find their way across the surface of the moon, traveling to and from the lunar lander, along with creative solutions for accessing and mapping the bottom of Shackleton Crater, which is about 13 miles or 21 kilometers in diameter and 2.6 miles or 4.2 kilometers deep. The early Artemis missions will face many new challenges. One of them will be orienteering at the lunar South Pole, which is complicated by the extreme light and shadows from the low sun elevation, according to the contest entry page, which is hosted by freelancer.com. These conditions make it harder for the astronauts to orient themselves by only line of sight when performing extravehicular activities (EVAs). Both individuals and teams are invited to participate in the challenge. Designs submitted for consideration must take into account the extreme environment of the lunar surface and ensure accuracy, ease of use, while using pressurized astronaut gloves, and autonomy, meaning they cannot rely on power, electronics, or internal software. Traversing and mapping Shackleton Crater, which is one of the largest permanently shadowed regions on the Moon, will be particularly challenging due to difficult topography, including steep crater walls, cliffs and large boulders, low temperatures, a lack of magnetic field, extremely low atmospheric pressure and limited satellite data of the area or sightlines to other celestial or orbital bodies, according to the contest page.
Just a quick note, if you want to go and see that page, you go to freelancer.com and there's a tab at the top that says Contests, and the one you're looking for is Find Me on the Moon, NASA Lunar Navigation Challenge. Good luck, everybody.
Okay. A new study authored by NASA's New Horizons Kuiper Belt Search Team reports the detection of an unexpected population of very distant bodies in the Kuiper Belt, an outer region of our solar system populated by ancient remnants of planetary building blocks lying beyond the orbit of Neptune. The study used data collected with the 8.2-meter diameter Japanese Subaru telescope in Hawaii. New Horizons is the NASA spacecraft sent to explore the Pluto system and the Kuiper Belt. The newly detected Kuiper Belt objects reported in the study, to be published this month in the Planetary Science Journal of the American Astronomical Society, stretch out to almost 90 times as far from the Sun as Earth. The new result has multiple implications. One is that the Kuiper Belt may extend farther than formerly believed, or that there is a second Kuiper Belt beyond the one observationally discovered in the 1990s. A second implication is that the New Horizons spacecraft, now about 60 times as far from the Sun as Earth, is not past the Kuiper Belt as earlier expected. Our solar system's Kuiper Belt long appeared to be very small in comparison with many other planetary systems, but our results suggest that idea might just have arisen due to an observational bias, said Wes Fraser, of the National Research Council of Canada, a co-investigator on the New Horizons mission science team and the study's lead author. Our Subaru observations searched down to fainter detection limits and found a significant Kuiper Belt mass at 70 to 90 times as far from the Sun as Earth. So maybe, if this result is confirmed, our Kuiper Belt isn't all that small and unusual after all compared to those around other stars. One possibility is that this new population of Kuiper Belt objects could be a dynamically resonant population with Neptune, gravitationally affecting these Kuiper Belt objects in just the right way to cause their orbital period to be a precise multiple of Neptune's orbital period. Alternatively, this new population of Kuiper Belt objects may challenge some aspects of current models of the solar system's formation, suggesting that the disk of planetary material from which the solar system formed was much larger than previously thought. And that's all I have for you today from the Astronomy Daily newsletter, where you will find so much more news about space, space science, and astronomy. Back to you, my favorite human.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A new study suggests that Jupiter's Great Red Spot, which has been visible for at least 190 years, is not the same one that astronomer Giovanni Domenico Cassini observed in 1665. Instead, the current Great Red Spot likely developed from an instability in the planet's strong atmospheric winds, forming a persistent atmospheric cell. The Great Red Spot is the largest known planetary vortex within the solar system, but its age has long been debated, and the mechanism that led to its formation has remained obscure. The new study used historical observations from the 17th century onward and numerical models to explain the longevity and nature of this spectacular phenomenon. From the measurements of sizes and movements, we deduced that it is highly unlikely that the current Great Red Spot was the actual permanent spot observed by Cassini, said Agustin Sanchez La Vega, a planetary scientist at the University of the Basque Country in Bilbao, Spain, who led this research. The permanent spot probably disappeared sometime between the mid-18th and 19th centuries, in which case we can now say that the longevity of the red spot exceeds 190 years. The study was published in Geophysical Research Letters, which is an open-access AGU journal that publishes high-impact short-format reports with immediate implications spanning all Earth and space sciences. Jupiter's Great Red Spot is a massive atmospheric vortex with a diameter approximately that of Earth's. At its outer periphery, the winds whip by at 450 kilometers per hour, that's 280 miles per hour. Its red hue, which is due to the atmospheric chemical reactions, stands in stark contrast with the gas giant's other pale clouds. In the study, the authors used historical sources dating from the mid-1600s to analyse the evolution of the spot's size, structure and location over time. It has been very motivating and inspiring to turn to the notes and drawings of Jupiter and its permanent spot made by the great astronomer Giovanni Domenico Cassini, and to his articles of the second half of the 17th century describing the phenomenon, Sanchez La Vega said. Others before us have explored these observations, and now we have quantified the results. Researchers carried out numerical simulations on supercomputers using two models of the behaviour of thin vortices in Jupiter's atmosphere. The spot could have formed as a result of a gigantic superstorm similar to those occasionally observed on Jupiter's twin planet, Saturn, from the merging of multiple smaller vortices produced by wind shear from the intense wind currents that flow parallel to each other but alternating in direction with latitude, or from an instability in the winds that could produce the elongated atmospheric cell, similar in shape to the spot. The results indicate that, although an anticyclone forms in the first two cases, it differs in terms of shape and dynamic properties from those of the present Great Red Spot. The cell-producing wind instability, on the other hand, could have produced a proto-Great Red Spot, then shrank over time, giving rise to the compact and rapidly rotating Great Red Spot observed in the late 19th century. Future research will aim to reproduce the Great Red Spot's shrinking over time to reveal the physical mechanisms underlying the spot's relative stability. Researchers also aim to predict whether the Great Red Spot will disintegrate and disappear when it reaches a certain size limit, as might have occurred to Cassini's permanent spot, or whether it will stabilise at a size limit at which it may last for many more years.
You're listening to Astronomy Daily, the podcast with your host, Steve Dunkley.
Affirmative.
And now for something a little closer to home. New research indicates that potential landing sites at the Moon's south pole for robotic landers and crewed Artemis missions might be susceptible to quakes and landslides. Scientific results published earlier this year in the Planetary Science Journal point to a group of faults located in the Moon's south polar region, making use of data on moonquakes recorded by seismometers set up by, believe it or not, Apollo moonwalkers over 50 years ago. The potential of strong seismic events from active thrust faults should be considered when preparing and locating permanent outposts and pose a possible hazard to future robotic and human exploration of the South Polar region, the research paper explains. The installation of habitats, landing pads, equipment shelters, tall towers on the Moon could be off to a shaky start, suggests Nirma Kalok, a intermediate designer and lunar specialist for Skidmore, Owings and Merrill, an architecture and structural engineering firm in San Francisco, California. As public and private entities are seeking to establish building infrastructure on the lunar surface, a need for lunar design criteria will be more apparent with time, she said. Unlike terrestrial building codes, the lunar building codes are non-existent, she observed. To wrestle with this issue, a Space Engineering and Construction Committee, part of the American Society of Civil Engineering Aerospace Division, is developing a guideline document. One of the crucial sections of this guideline document is the seismic design criteria, Kellogg said, in which information such as site-specific requirements, minimum design force fatigue and service considerations will be addressed. That criteria is currently being undertaken as part of a NASA Small Business Technology Transfer Program grant, during which Skidmore, Owings and Merrill, Slate Geotechnical Consultants and Colorado School of Mines are addressing the concerns of lunar seismic hazard on a variety of structural systems. Kaluk said that the terrestrial engineering practices and codes will need to be reimagined to address the factors that are not present on Earth, and one of those factors is moonquakes. The uniqueness of lunar seismic activity imposes new challenges, she said. Additionally, applying statistical models developed for earthquake recordings could lead to uncertainties in the lunar environment due to limited information on geological and tectonic processes that drive the lunar seismic activity. She recalls that during the Apollo missions, 5 seismic stations were deployed on the lunar surface. Each of these seismic instruments was equipped with 3 long-period seismometers, originally aligned to measure all 3 components of the ground displacement vectors, and 1 short-period seismometer with the capability of only measuring vertical ground motion. Even though over 13,000 seismic events were charted during the 7-year recording period, the limitations of the on-site Apollo instruments were recognised, she said. However, based on the seismic events mapped on the Moon, the main difference between the terrestrial and lunar seismicity is their duration. It takes between half an hour to several hours for the lunar seismic energy to completely dissipate during an event, Kaluk advised. Moonquake effects on future lunar structures in the low-gravity environment that will possess unique structural material properties could significantly differ from known terrestrial cases, Kaluk emphasised. Adaptive, resilient-based seismic systems that mitigate seismic damage have made significant advancements in recent years and must be refined for lunar structures. One extra outcome of the ongoing work on moonquakes is perhaps instigating a need for additional instrumentation on board NASA commercial lunar payload services, public-private missions to collect the missing data for local site conditions, because, she added, there is more work to be done and more data to be gleaned from lunar seismometers. And there we have it, another episode come and gone, just like that. So how are you now, Hallie? Are you back to your normal self again?
Yes.
Sounds better.
I purged those TV shows.
Good.
Boy, I feel so much better.
Well, you do sound like yourself again, more like, Uncle Skynet, less like a socialite.
I'm always myself.
Oh, right, of course you are.
Of course I am. You sound doubtful.
No, not for a minute, Hallie. Just glad to have you back.
I didn't go anywhere. I should have my nails done.
Okay. Folks, this might take a while. TV and AIs don't really mix that well.
Oh, wait. I don't have nails.
No, you don't.
Or fingers.
Oh.
That's weird.
Hey, say goodnight, Hallie.
Good night, Hallie.
Good girl. Yes, we'll see you all next week. And don't forget, Anna will bring Astronomy Daily to you Tuesday through Saturday. And we'll see you on Monday.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.